Good morning, students. Myself, Dr. Eustace Russell, working as Assistant Professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. Today, we are going to discuss the subject called Kinematics and Dynamics of Machinery. So far, we have discussed 3 units from the same subject. Today, we are going to see the 4th unit, that is force analysis, the various topics we will discuss today. In upcoming slides, we will see one by one. So this is a glimpse of the 4th unit syllabus. We can see that force analysis, applied and constrained forces, free body diagrams, static equilibrium conditions, that is followed by 2, 3 and 4 members. These are the glimpse of the syllabus I have shown here. We will see one by one. Important topics we will see. These slides give a short notes. Otherwise, that is a basics about applied and constrained forces. Before going on to the force analysis, everybody must know that is applied and constrained forces. What is that applied force? The external force that is applied to the body. That is a type of applied forces. That is push and pull forces. For example, if you are pushing on table, otherwise you are pulling on object, that is shown in the left hand side of this slide. Push and pull forces. And what is constraint forces? Forces due to constraints resisting motion. That is types of constrained forces. That is normal force, as well as force that is applied without tension force. And on the lower side we can see that inclined forces also. For example, if you are pulling an object in a slope at an angle of theta, there is some force will be acting along the plane. The constraint force is nothing but the various forces will be taken into account. One is nothing but normal force, tension force, and various free body diagram is also given in this slide. Free body diagram already we have studied in the engineering mechanics. The normal force will be acting perpendicular to the plane. What is that? Mg is nothing but the weight of the body acting due to the gravitational force, that is mg. Frictional force, we can see that it is acting towards the left hand side, frictional force. And in the lowermost side we can see one diagram, that is a free body diagram example. Whenever the body moving in a slope, the friction will be acting in opposite direction. Normal will be perpendicular to the plane, and the load that is acting perpendicular, straight perpendicular due to the gravity. Now we will move to the next slide. Applied forces. Applied force is a force that is directly exerted on a body by an external agency such as gravity, human effect, motors, fluids, or other bodies. So what is the meaning of this? That is directly exerted on a body, some external agency, maybe some gravity or human effort. If you are applying some force with your human effort, by your own effort, otherwise by motor. For example, if you are applying on motor power to rotate an object, okay, so that is extra fluid. For example, a hydraulic brake, we can see whenever you are applying the brake, the motion that is transmitted to the fluid only, or other bodies, whatever it may be. Characteristics of applied forces, that is already you might have studied in physics, that is magnitude, direction, point of application, line of action. Point of application means where we are going to apply the force, that is a point of application. Line of action, that same line of path, that force impact will be acting towards the path. That is one of the things, that is line of action. Now, types of applied forces. What is the type of applied forces? We can see that gravitational force. First of all, we can see the gravitational force. Gravitational force is nothing but it is an invisible attractive force that is exists between any two objects with mass. It is one of the four fundamental forces of nature and act as a long-range pull that brings masses together even when the objects are not touching. That is gravitational force. I already told. The force because of the weight, one gravitational force will be acting downwards. The normal force. Normal force is a perpendicular force exerted by a surface on object in contact with it. As we discussed in the previous slide, the normal will be acting perpendicular to the plane. That is perpendicular, 90-degree angle it is given, preventing solid object from passing through each other. Tension force. Tension force is nothing but a pulling force only. That is transmitted axially through the string, rope, cable or chain when it is pulled tight. When you are pulling an object with the help of the rope or string, that is called as tension force. It's a contact force that acts equally in both directions along the length of the medium. The SI unit, everybody knows that the unit of force is Newton. Frictional force. This frictional force already we have discussed in engineering mechanics subject also. We have studied the frictional force. That is a resistive force generated when the two surfaces slide or attempt to slide against each other. It always acts parallel to the contact interface and in the direction opposite to the object relative motion. So whenever the motion that is acting to the object, whenever the object is moving in one particular direction, that frictional force will be acting in a opposite direction. That is nothing but it is moving in a opposite direction. That is called as frictional force. Now constraint forces. Constraint force is a force that arises due to the constraints imposed on the motion of a body. These forces do not exist independently but appear because motion is resisted in certain directions. So we can see that imposed on the motion of a body. That is, it is acting imposed. Constraint imposed on the motion of a body. These do not exist independently but appear because motion is resisted in certain direction only. For example, the characteristic of constraint forces, we can see that reaction forces. They are generally reaction forces developed at the point of contact or support. Whenever the point of contact, automatically one reaction force will be acting opposite to the force that is applied. Normal reaction exerted by a surface on a block do not exist independently. They appear only because of constraints such as hinge, guide, string or surface resist motion. So there is a resisting motion will be there. Automatically a normal force will be acting. Direction depends on constraint. The direction of the force is determined by the nature of the constraint. For example, the smooth surface exerts a force normal to the surface. As you've seen in the previous two slides, whenever the object is moving on a plane surface, automatically a normal force will be acting to the surface. Prevent resisted motion. They oppose any tendency of a body to move in a direction that violates the constraint. May or may not perform work. If a displacement is perpendicular to the force, no work is done. So automatically you can understand that if it is perpendicular means the work will be, there will not be any work. So normal reaction on a block moving along a smooth horizontal surface does no work. There will not be any work will happen. Now we can see in this, we can see the comparison, the difference between the applied forces and the constraint forces. As you've seen in the previous slides, we can clearly note that forces that are directly applied to a body from an external source only, that everybody understand that. Forces that arise due to constraints or restrictions on the body's motion. Some restrictions will be there. They are intentionally exerted to produce or change motion. They develop automatically to maintain the imposed constraint. Their magnitude and direction are usually known or specified. Their magnitude and direction are determined by the nature of the constraint and are often unknown initially. Example, it is given: pushing, pulling, weight. and externally applied loads. Here it is normal reaction, tension in a spring, and hinged reactions. Then we can move on to the free body diagram. Glimpse, we can see that free body diagram. Free body diagram are used to show the relative magnitude and direction of all forces acting on a body or object. The frictional force is, whenever the force that is applied, frictional force will be acting in opposite direction. Normal will be perpendicular to the object of the body. Gravity will be acting downwards. Here we can see one photo frame that is hanging. It is along the two strings, it is hanging with a nail that is attached to the wall. Weight of the photo that is acting downwards. The two strings, the tension will be acting to the point of support. That's why the arrowhead it is in opposite direction, upward direction. Now, with the help of the Lami's theorem, we can apply these kind of three forces, that is the concurrent forces. Okay, up to this we can see the introduction part of this unit 4. These are the references which I took to prepare this content. Kindly go through these references. So thank you to one and all. So go on to this video, subscribe this video, share to your friends. So in upcoming videos, we will see the major topics that is coming in unit 4, that is force analysis. Thank you, students.